In this video, we'll implement our audio and interface settings using our settings system. So, I was supposed to upload this 2 weeks ago. Audio settings are an integral part in any video game. Being able to control what sound you want to hear is important for players' experiences. Alongside that, players may want to modify their experience with their UI, whether they want to enable or disable certain UI elements or resize things to fit their needs. An interface settings section will help them control what they want. We'll be making a mini-map for this section that will be very simple, but first, let's just start off with the audio settings. We'll first start with a minor fix. Even though we changed the base menu to have a stretched rect transform, we made some scene changes at some point that expanded the text description incorrectly. Next, we're going to add 3 sliders, a dropdown, and a toggle. The sliders will control the master, music, and sound effects volumes, while the dropdown and toggle will control the audio type and mute settings respectively. We've already done this numerous times before. We'll update each label, rename the sliders, rename the counters, assign the text descriptions, and fill out the text helper. We'll also slightly adjust the text counter width in order to accommodate a triple-digit value. You may need to reposition and expand this depending on how big you want your counter to go up to. You can also align it so it expands from the left rather than from the center. We'll then create an audio mixer. This will be where all the sounds will be controlled. Under the master group, create a music and sound effects child. This is so that if we change the master setting, it would globally affect all sounds connected to it. In order for us to change these volume settings, we'll need to expose the parameters. Right-click the volume setting under attenuation and expose the volume component for each sound group. Once exposed, rename them appropriately. Create a music player game object and add an audio source component. You can attach any music file you have, but I will be using a song that is free to use. Ensure that the output is using the music sound group, and now we should have everything prepared. We'll create a new script called Comp Audio Settings, but before we start, we should update our save script to accommodate the new settings. We'll need 3 floats for the master, music, and sound effects volume, an integer for the audio type, and a bool for our mute button. While we're here, we'll also add in our interface settings. This contains a float and a bool for our minimap. We'll then copy and paste all these variables over to our default settings scriptable object. Inside SL settings, we'll assign the settings data using our default settings. Now it's time to tackle the audio settings script. We'll need a reference to our settings scriptable object and our music player. The music player will come into play later. We'll then need the 3 sliders, the audio dropdown, and the mute toggle. Add in the audio mixer and our mute value. We're going to have a sound range between -30 decibels and 0 decibels, and this mute value will set the sound group to -80 whenever we set the slider to 0. The main reason I do this is because the range between -80 and 0 decibels is rather large. A sound at 50% or -40 decibels of the slider would almost be completely gone. We want the range to be a bit smaller so that the player has a better range of sound to go through. We'll add some constant strings. The first 3 must match the slider names that you assigned in the scene. The second 3 must match the string names you exposed in your audio mixer. Copy and paste the receive slider value and slider changed functions from game settings and over to our script. We'll then make several changes. Whenever we move the slider, we'll constantly call slider changed to update the sound in real time. In this case, if the slider is the master volume, we'll set the master volume using setFloat while passing in the master mix string and the converted slider value. Remember, we use this function to convert our virtual range of 0 to 100 to our actual usable range of -30 to 0 decibels. Now, if the slider value is at 0, we'll immediately set the master volume to negative 80 decibels. This will essentially mute the group whenever we move our slider to 0. With that all set, we'll just do the same for our music and sound effects volume sliders. Under Receive Slider Value, we'll just adjust the correct settings value to the settings file by converting the slider's virtual value to an actual value. Remember, this is called by an event from Comp Slider. Whenever they release their mouse, this is called. Next, we'll initialize our sliders. First, we need to update the slider value to match the value found in our settings script. We'll then need to assign listeners to all of our sliders so that they call the slider changed function whenever they want to change their volumes. Once set, we'll go back to our scene. We'll assign our audio component, but first, let's make a scriptable game object for our music player. We'll add our initialized game object component script to our music player and create our music player game object. Assign the scriptable object and the game object itself to this component. Back in our audio component, assign the music player. Assign all the sliders, slider counters, their appropriate range of -30 to 0, the dropdown, toggle, audio mixer, and our mute value of -80. Lastly, we'll need to update our load manager. For this, we need our music player and our audio mixer. Now, this is kind of gross, but we'll copy and paste our mix strings over to this file too. It's gross because if, for whatever reason, you wanted to change the exposed volume name, you would need to update the audio settings and the load manager. You can just change the visibility of the string, and constant isn't really needed here, but to save time, I'll just copy and paste it over. Once complete, we'll set the corresponding floats to the values found in our scriptable object. If the actual value was -30, we'll assign the volume to be the mute value. Do this for all of our sliders. Once complete, assign the variables to our component, delete the settings file, change the default audio settings to have the values of -10, and run. If done correctly, the master, music, and sound effects volumes will start at a virtual value of 67, and you can adjust it accordingly. You'll notice that whenever we max out our slider, the saved value is close to 0, but not actually 0. There is a rounding issue that happens at this point. Inside Comp Slider and under the Convert Virtual to Actual function, we'll fix this rounding issue with a rather dirty solution. We'll just make the ratio and return value a double and cast the result to a float. This fixes the rounding issue. Next, we'll do the dropdown and toggle. These are pretty simple enough. We'll start off by setting the dropdown and toggle values based on the settings file. We'll then add listeners to our dropdown and toggle calling two separate functions. The first function is called audio type changed. It'll take in a dropdown value, and depending on the value itself, it will change the audio type to stereo or mono. Now, here's the difficulty of changing audio types. Whenever you change audio types, the audio type does not update immediately. You need to reconfigure the audio configuration and then reset the audio setting to apply this new audio type. However, resetting this audio configuration also stops all sound. We want the music to continue and continue where it left off. After getting the configuration, the audio source component, and the time at which the music left off at, we'll change the config speaker mode to be stereo or mono. If the mute option is not on, then we'll just reset this audio setting and replay our music player. Lastly, we'll update the settings file to reflect the correct config chosen. The second function is called toggle mute changed, and this will change our audio listener to have a volume of 0, muted, or 1, not muted. Once finished, we'll copy and paste the majority of our first function over to our load manager. We'll modify it to reflect the settings file, and if the settings file has mute enabled, we'll mute the audio listener again. With all that set up, make sure you delete your settings file and assign the drop-down values. You'll now be able to mute the sound, and you can change the audio type between the two options given. Ensure that the scriptable object is updating properly, and now you're pretty much finished with the audio settings. Now it's time for the Minimap. Remember, it will be very basic. We just want something to change for our interface settings. First, we'll add another camera and place it above our player. We'll create a render texture and assign this texture to our Minimap camera. Change our environment to be under a new layer called Environment. Under our Minimap, change the culling mask to only see the environment. Now, you're going to have to make a circle asset of some sort and add that to your project. The one I'm using is a bit low in resolution, so you'll notice some jagged lines in our end product. Once you have the circle, let's create the UI element. First, we'll add a canvas and change some settings. The render mode should use screen space camera, and the canvas scale should scale with the screen size at a resolution of 1920 by 1080. Add the initialized canvas camera script to this game object and reference the canvas and the camera scriptable object. Now under the UI, add a game object called Minimap. We'll make a scriptable object and initialize it using this Minimap game object. Make sure it's anchored to the top right with a width and height of 250. Then, we'll add an image as a child of this Minimap game object, assign our circle image, and stretch it. We'll also offset the minimap to be a bit from the corner. Recolor this background image. Add another image called Map. We'll stretch this image and slightly scale down the map. Make sure you add the mask component to this game object. Under this map, we'll add the render texture and stretch it. If done correctly, the render texture will be successfully masked. The most important thing revolves around the minimap rect transform, so do not change it after anchoring the map to the top right. We'll add a sprite just above the player. I just used the drop-down arrow that's available through Unity. You'll notice that it's very blurry. This is because of the resolution of the arrow. If you want sharper images, you can create your own player indicator at a bigger resolution. We also need to add this indicator to the layers. Make a layer called Minimap and include that layer under the Minimap camera while excluding it from your main camera. With that done, you'll see that the minimap doesn't follow the player. So we'll just add another script called CompFollowPlayer and simply just update the camera's position to be that of the player's position. Assign it to the minimap camera, add the offset, and there you go, a very simple minimap. Now to implement the interface settings. Add a slider and add a toggle that will control the minimap scale and visibility. Again, change the slider names, texts, labels, and toggles to match their respective tasks. We'll also reduce the height of the right side page inside our audio and interface setting, just so that it's more clumped together. Once finished, we'll create our comp interface setting script and start working on each minimap component. We'll just need the setting scriptable object, the minimap, the slider setting, and the toggle. We'll also need the slider minimap constant string. Again, copy and paste the slider changed and receive slider value functions over to the script. Under Receive Slider Value, replace anything to do with the master slider with the minimap slider. Under Slider Changed, we'll change the scale of the minimap in real time. Since we're scaling it uniformly, we'll just make the local scale change with the same scale value. Next, we just need to properly initialize our slider. We'll set the slider value to a virtual value and assign the listener to our slider 2. We'll then start tackling our toggle. It's pretty much the same as our toggle mute function, but this time we just turn the minimap on or off. We'll then set this toggle using our settings file and assign our listener to the toggle. Back in the project, we'll assign the settings and the minimap game object. Our slider will use the minimap slider and the counter. We determined that a maximum value of 1.5 and a minimum value of 0.75 was sufficient for our minimap. Add the toggle and make sure the slider has the correct slider event under Comp Slider. Lastly, we just need the load manager to set the interface correctly. We'll need the minimap game object, and then we'll simply set the scale and the visibility of the game object based on our settings file. Ensure the default scriptable object has minimap on and scale as 1 and delete the settings file. Once you test it, you can see the minimap scaling based on the size you give. You can also enable or disable the minimap as you wish. You can test it in build and it should work exactly the same. Make sure you delete your save file. Remember, the reason we delete our save file is to replicate a fresh start for new players. Once the player has their game ready, the settings file would never be deleted. So, whenever you rerun the game, all settings and options should save properly and remain the same. Make sure everything is working, and with that, we're done with our audio and interface settings. We've now gotten to the point where our settings menu is basically finished. You can leave it as is, but if you wanted to add more functionality, you should have all the tools needed to implement them into your settings menu. All that is left is to add some polish. This includes adding various art assets to make the settings menu look better, and maybe even adding a reset button on every page. Regardless, we'll finalize everything in our final settings tutorial. Anyway, I'll see you next time.